the great tree of life that unites all of the species on this planet. And I'm going to stress that relationships do matter, that information can help us cure disease, develop new medicines, improve crops, and make more informed environmental decisions. For these reasons, we need to work together to improve our knowledge of the tree of life. But until just a few months ago, we lacked a comprehensive tree for all of the several million species named on our planet. 30 years ago, when I started building trees of just a few hundred species, I was told that this was an impossible task. And some simple math reveals why. When we build trees, we use computers. The computers will put those species together in all possible combinations, that is, try to build all possible trees. And then it will find the tree that is the best match to the data. Sounds easy, right? And it starts out quite simple. So far, so good. But you can see these numbers begin to increase very rapidly, logarithmically, in fact. That until by the time we reach just 20 species, we are now approaching 1 mole of trees. Avogadro's number, 6.02 times 10 to 23rd. One of the few things I remember from chemistry. No wonder I got a B-. And when we are trying to build trees for 200 species, we're now beginning to surpass the number of atoms in the universe. Whoa, we do have a problem. But we did it. Our group did it. We were able to build the first comprehensive tree for all 2.3 million species that have been named on our planet. Through a perfect storm of technology, computer power, and the DNA sequence revolution, DNA data allowed scientists around the world to add numerous species to this tree. But I think it's really hard for people to comprehend a tree of that size, of that many species. So to help, we have a prop. Unfurling is a species tree of just 1,000 species. This is printed at 12-point font, a normal font size, single space, and that looks quite large, doesn't it? But the actual tree of life, if we were to print it at the same scale and the same font, would require the Empire State Building to display. 4 sides in the Empire State Building. 14 Empire State Buildings. 4 sides of 14 Empire State Buildings. So the tree of life is truly immense. Without further ado, let's take a look at the tree of life as we now understand it in a very simple circular format, with the center being the origin of life and all of the species arranged around the periphery or rim. You might ask, where do I fit in on the tree of life? Well, that arrow points to the location of the mammals, our group. We can zoom in, take a look at the mammals in the same circular format, and that arrow now points to us, to our species. These big trees are humbling. They show quite clearly we are just one small branch on the tree of life. Now, the idea or the concept of a tree of life is not new. It has a rich history. Darwin, in fact, talked about the great tree of life. And the only illustration in the origin of species, it's not a finch, it's not a map of the Galapagos Islands, it's a simple tree of relationships. Darwin knew, as you know, is that relationships matter. So we've come really a long way, but we have a long way to go, because this is just really a first draft of the tree of life. It's now time for people around the world to add more data, add more species, and improve our knowledge of the tree of life. It takes a village to build the tree of life. Now notice the colors on this tree. They range from red to blue. Red is where we have DNA sequence data. Blue is where we have none, and colors in between various amounts of DNA data. You can see that this tree is mostly blue. And in fact, we have DNA data for only 17% of the species in this tree. Bottom line, we really don't know very much about life on our own planet. Add to that, there are at least 10 million more species on our planet, undescribed, unnamed, still not in this tree, and you can see that we really have a long way to go. Now, there are numerous downstream benefits to the tree of life to our own species. Let's consider drug discovery. This plant is the Pacific yew. Most of our medicines comes from plants, and this is the source of a cancer-treating drug called Taxol. But the problem was that the Pacific yew is not a very common plant. So how to find a better source for this medicine? Well, you could randomly survey thousands of plants, or you could say, relationships matter. Let's use the tree of life. And that's what was done, and a close relative of the species was found in Europe that produces the same compound, and that species was common. And it became the source of Taxol until it was eventually produced synthetically. The tree of life is very important for crop improvement. What if we want to make some of our crops more water efficient, which is very important today? Let's use squash as an example. Why not use the tree of life and see if there are any dry adapted relatives? That's what this scientist has done. She's used the tree of life, found that there is an arid adapted relative of the squash in the southwest of the United States, and she's now collecting seeds that can be used for breeding purposes. The tree of life is an essential tool for conservation. This bird was known as the white-winged warbler, which is very hard to say in a TED Talk, by the way. But DNA sequence data in the tree of life revealed that it really wasn't a warbler. It's a separate line of birds, one that really should be in its own family. That, coupled with the fact that it's only found on one island, has heightened the conservation concern for this species. Trees of relationships are the front line of defense in combating disease, for tracking invasive species. We can even use the tree of life to predict where species are going to be in a rapidly changing environment. How can we do that? Because relationships matter. Closely related species are going to respond in a very similar way, whether it be increasing temperature or decreasing moisture. So the tree of life is an essential tool for our own species. Imagine a world in which we more rapidly cure disease, develop new medicines, improve crops, make more informed environmental decisions. For these reasons, I hope we can work collectively on a major biodiversity initiative to improve our knowledge of the tree of life over the next decade. We need more funding, we need more awareness, we need more involvement at all levels. If we do nothing, best case scenario, we lose a few medicines, our ability to improve some of our crops. Worst case scenario, with a rapid rate of extinction of species on our planet, we face massive damage to ecosystems and the loss of thousands of species, thousands of unknown species, many of which may have been beneficial to our own species. Imagine the loss forever of a species that could have cured cancer in your children, provided a life-saving medicine that could have saved the lives of your grandchildren. Lost forever before we ever knew it was there. Relationships matter. Biodiversity matters. It's staggering how little we know about the family tree for our own planet. We have DNA sequence data for only a fraction of the species on this tree. This tree should be more red than it is blue. Plus, there are the millions of species on our planet still undescribed, unnamed, not yet in this tree. I tell my undergraduates that each year, scientists discover and name about 14,000 new species, which sounds really impressive. So you stop and think about that for just a second and realize that that rate, it's going to take us at least 900 more years to describe and name what we think is still here. Do we really want to wait that long?